Hello, this is Rick Guptill. This is the third video in the welding process. Here we have the same part that we've been working with and the weld table now. So we're going to take a look at this particular weld set. So you go across here to program each weld. Start with the vector, what I call the joint vector that you're going to move to. Whenever you start a program for welding a robot, you really want to figure out where the robot's going to start, and everything goes from there. So we chose this one. It's kind of arbitrary. It really depends on the torch. It depends on this hose. Maybe there's going to be a hose problem. It depends on kind of a lot of things. So it's case by case, and it really helps to take some time and to figure out where the starting position of the robot is, because you don't want it to run out of joint limits. Sometimes you have complicated joints that go around a curve, and you need a starting vector and an end vector so that the robot moves between them gradually as it does the weld. And then also the touch JV. And in this case, I'm going to use the same one as the start. Make it easier. It's not a complicated touch in this case. The touch elements are where you're going to perform the touch. So if we look at here, we made 3 of them here, and what it does here is it actually rips the torch off the robot, and it says, okay, I'm going to touch with the tip down. It's electrical, so when it makes contact, it touches that. So it's really easy to change this around. You can just go in here and say, well, you know what, I think touch would be better maybe over here, or maybe we're going to touch it on the edge, wherever it makes sense. And then you say, okay, I'm going to save that touch position. And then the 30 millimeters is usually the, whoops, not 300, 30 millimeters is usually the distance that the touch starts. So we're assuming that the variations in this part placement are going to be within 30 millimeters, probably better like 15 millimeters, and then here's where it can be high. So you can just lift that up and say that's the high. So what we've done is now we've edited that touch position, so then the robot will be able to reach those when it touches that. And so the face, we're going to touch on the right side of the torch. It doesn't really matter where it touches, because it's the final direction that it takes, and so that's going to be the X direction, and then it wants to touch the edge. So here's how it's going to touch the edge. Okay, so really you go through and you decide where you're going to touch for these. In this case, what we're going to do, and then this puts the tool back on the robot, we're going to take those touch elements and we're going to say, let's not touch the base, because it's such a thin base, it's probably held down pretty well. We know where that flat plate is. We don't really need to touch it, but we do need to touch the face and the edge. Okay, and then these are moves. This inner touch is a move after the touch, and pre-touch is after, and I'll show you what those mean. And then sometimes you touch at the beginning of the weld and the end of the weld. Okay. Safe elements are what I talked about. So pre-touch, it's gonna take the touch JV, because we taught that, and it's gonna use the gantry to offset 100 millimeters in the X, Y, and 1,000 in the Z. So it's gonna move it up a meter, get it in the touch position. So the pre-touch is getting ready to touch, and there's no rotary table in this case. And then touch, kind of the same thing, except it brings it down closer. It's gonna bring it off 300 millimeters from the marker. It's relative to the weld, wherever the weld is. And then you'll see the weld uses the weld JV, brings it 80 millimeters, so it's really close. It's getting ready to weld. So these are kind of like safe moves for the gantry to move the robot around. And then weld elements here. It's going to move up 30 millimeters after, and there's actually there's a high depart, and then there's a getting ready to weld depart. That's this one, the low depart, and then there's the weld, and then it goes low, and then it goes high. So those are these numbers here. These are for master slave, and then this has an idea of, if it can't find the weld because there's a collision, it's going to first change the work angle. Okay, and here's the min and the max of the work angle. It's going to start at a 45. And then if changing the work angle doesn't free it from the collision, then it's going to look at the push angle, finally the orientation, and these are kind of the things on that. We have some good examples of how it moves the torch out of collision. This is really how to move it out of collision so you get a good weld, but you want to move it as close to possible as, you know, when it starts off to the weld that you want it. Okay, so once these are all set, the subprograms also just you set the touch JV and the weld JV, the start and the end weld JV. But see, once we figured that all out for this weld, now all of these welds can be done. Okay, so all these baffles, you can see the first weld on all of them was all figured out because they're all identical. All right, so if we just say let's just weld that one, well, I'll tell you what, let's start here in the next video and we'll weld this one and then the next one. All right, thanks.